So first question, I guess the first one might be for Renske. Um, how do you explain that afternoon light is apparently less damaging, if it is, if following a good take of morning light?
I think that's a really good question. I think it's difficult because I think when we talk about light, you cannot just talk about a pulse as an independent event, right? Like from the moment we wake up, we get a certain amount of light, and this continues on until we go to bed. And I think the influence that light has on us is going to be dependent on prior light history, as we call it. So if I go outdoors in the morning because I have to walk my dog, I get a lot of lighting then. And then the effects of light in the evening, for example, are probably going to be a lot less intense had I not gone out all day and gotten any outdoor light exposure, for example. So I think it's kind of important to look at light exposure as a sequential event. Yeah. Does that answer the question? I hope.
Yeah. And from Laetitia as well, if light pollution disrupts human sleep, how about the circadian rhythm of wild animals? What is the latest research on it?
Yeah, also excellent question. I think actually that the disruption on animals is way bigger than it is on humans. I mean, after all, if we talk about light exposure at night, so outdoor light exposure, of course, we sleep with curtains closed, we sleep with other tools. So there are ways that we shield ourselves from artificial light at night. I think for animals, much less so. And there's some really interesting work that's being done about light at night and the influence on migratory patterns, on bird and mate choice, and all these kind of things. And I think, yeah, the research is showing that it's really, really bad for all these ecosystems, actually, and that the effects are much bigger than for us humans, even. So it's very worrisome. Yeah.
Thank you. Another question from Annelies. Did the duration of sleep differ between the early and the late group?
Excellent question. And I didn't go in all the details of the experimental design. So we corrected all our models for sleep duration because, of course, it's easy to, or it's logical to assume that those that go to bed late sleep less because of obligations, work, children, maybe. But there weren't actually large differences between the groups. So people slept about equally long. And we corrected all our models for sleep duration. So the effect of timing of sleep on health was independent of how long people slept.
Okay. Considering the increased exposure to artificial lighting and the detrimental effects this has on our health, what could the long-term implication be for the evolution of the human race?
Ah. Uh, that's a difficult question to answer. Um, I don't know. I don't know if we're at the point to make any recommendations or conclusions about that. Um, I think, as long as we still try to get outdoor light exposure, as long as we still try to maintain, let's say, normal light exposure rhythms, I think we'll be okay as a human race, but this is highly speculative. Yeah.
Um, so there is three questions that might be together. So can older people improve their sleep by moving to mid or low latitude areas with longer daylight hours?
I don't think that has been proven yet, but it's kind of what the data would suggest in a way. Yeah.
Okay, and as well, is there a difference if people spend some outdoors time, sorry. Is there a difference if people spend time outdoors active or sitting? And how much time and at what time does outdoors activities?
Right. So that's an excellent question. We're actually looking into that right now. It seems to suggest that the effects on sleep-wake consolidation are better if people are active. So if it's really an afternoon, let's say a stroll or a walk outside versus sitting on a bench. But we have not really tested this in a methodological way. So it's a little bit speculative. Yeah.
Um, Another one thing, thank you for the wonderful session. And may I know whether spectral composition of light has any impact in altering the sleep quality?
Yeah, I think this is also one of the topics that has been explored a lot, where people talk about the blue light hazard, basically being exposed to light of the shorter wavelength region, because that is most active on the circadian slash melatonin system, let's say. Um, I think the data right now is kind of showing that it's really any light of certain intensity, and it's true, blue light is a little bit more potent, but I would say any light can have these effects on sleep and sleep quality, just as long as you get enough of it, or yeah.
Yeah, I'm trying to find a question for Jeff, and then we'll come back.
Yeah.
um, I'm trying to, I think.
Well, I agree that what I talked about is less applicable to,
Yeah,
to people's daily lives. I would
okay,
say about
maybe.
I
Yeah,
would say
sure.
about light exposure that there's even studies to show that red light, which is supposedly not modifying at a certain intensity, will even start to cause problems. Even in mice or in animals where we presume that they don't have the retinal structure to interpret the light, as these lights start getting broader in their frequency response, they start actually triggering circadian issues or things like this. So yeah, I think it's always the exposure level and not just the wavelength. So,
Yeah.
so what was the question? Sorry, Bash.
No, sorry, I just, so I continue. Sex differences in aging effects of sleep fragmentation and menopause.
Ah.
Any idea?
Excellent question. Something that at least in humans is really not that much known about. I think sleep-wake fragmentation is common in anybody who ages, and we do know that menopause has a big, influence, and it's a big deterioration on sleep quality, but it's really emerging research. So at least in humans, we don't know so much about it yet. We kind of look at it as a whole, but maybe Jeff has an idea about the perspective in mice.
Mice menopause?
I don't know.
I
I
mean,
guess
look,
aging, sex
yeah,
differences, I guess.
exactly. So we do have this problem in animal research in general that we tend to focus on young male mice. And the excuse is always, well, because they're so similar. So then we don't have
Yeah.
to think about things like female hormones and,
Mhm.
aging. But it is true that at least over time, in terms of what we see in male and female animals, that they age differently, that there is more fragmentation that occurs in female mice, even though they sleep a bit better when they're younger. But then as they get really old, male and I say 2 years old, a year and a half, that's a very old mouse, the sex differences tend to disappear. But part of the problem is we just don't have enough research on it because it introduces extra variables that researchers don't want to deal with. So
Yeah. Yeah, I think this is a very interesting push that is starting to happen, though. Like,
mhm, absolutely.
funding institutes and such are really pushing for us to include all genders and
Mhm.
take sex-based differences into account. But the research is really lagging for now. Yeah, it takes
I
time to
agree.
catch up. Yeah.
Absolutely.
Yeah.
Okay, so again, with different blue lights. So blue light is a key factor to consider when using virtual reality in the evening, especially right before sleep. In your opinion, to what extent can the negative effect of blue light be mitigated, such as through the use of an eye protection or low blue light mode, or by scheduling virtual reality use earlier in the evening rather than immediately before bedtime?
Yeah, this might be slightly controversial, but I'm a firm believer that blue light blocking glasses are not going to save you. As I indicated before, I think it's really any light exposure, and I think the idea of having, let's say, night shift on your phone or blue light blocking glasses, and then you can do whatever you like is it's probably a little bit misleading. I think your safest bet in terms of light exposure and activation and postponing of melatonin, I guess, would be to schedule your virtual reality earlier in the evening.
And if I can maybe add another small question about it, if you spend more time outside during the day, I think the light in the evening has a little bit less impact than if you spend your day inside, right?
Correct. Yeah. I think this has not been like methodologically shown, let's say in a dose dependent manner, but I think this is, I would agree with that. I do think if you get a lot more light during the day, you're a little bit more resilient to light in the evening or at night. Yeah.
Sorry. So I have a question about thanks for sharing the amazing results of better sleep and less fragmentation caused by daylight. Since the study is in larger group, would it be possible to translate this effect into financial benefits, like reduced health costs?
Yeah. That's a good question. I mean, I'm not an economist. I'm a biologist. I don't think about finances outside of my own finances, I guess. So I have not really considered this. I think it's hard to put a number on the health cost. I know there was an initiative from the Good Light Group actually to try and put a number to the benefits of getting better sleep. And I think they were successful in that. I think it's on the Good Light Group website, actually. Yeah.
Exactly. So when we discuss how light affects sleep quality, is it more informative to look at cumulative light exposure across the entire day or at exposure during specific time windows, morning, afternoon, evening?
Yeah, it kind of depends because on the one hand, I do think you cannot look at light as a singular event, let's say the afternoon or the morning, independent of each other. At the same time, we do know based on the circadian system that light at different times of day has different effects. So I would say both, I guess. Like there's lots of research showing that light at certain times of day is more potent for example, phase shifting the circadian clock or changing circadian amplitude. So then it's more, it makes more sense to look at light at certain time blocks. But at the same time, as we kind of talked about, like, you're more resilient to light in the evening if you got more light during the day. So I would say the answer is both for humans at least. Yeah. I don't know how do you handle that with animals, Jeff?
Yeah, good question. I mean, with animals again, we try to control as much as we can. So because the more you can control the variables, the less you have to explain them after the fact. There was a big controversy, for example, at some point that we were using fluorescent lighting for all of our experiments, which, I'm sure most of the people, if not all of you, know the spectral composition of fluorescent lights has nothing to do with the biological construction of the retina. And it even flickers, and we don't even know if the animals perceive these flickers and things like this. And so, I mean, from my perspective, I think the best. Now I've forgotten exactly what is the original question because now I'm starting to think. What was the original question, Virginie?
Yeah, if I lost it. What is it?
I think if you should look at light exposure in blocks, let's say morning,
Yeah,
afternoon,
yeah,
evening, or
exactly.
sequential in a way.
Sequential, yeah. I mean, for us, it's very artificial, the whole thing, because we always keep this 12-hour, which would be a equatorial light dark cycle, I guess.
Yeah.
Also, it gets shifted depending on the researcher. Maybe they want to work earlier in the morning, so then they start shifting the animals. Or if they need to do experiments at night, they may even flip the light dark cycle, which supposedly doesn't have any long-term effects on the animal after about 3 weeks, but again, not really well discussed. With a rodent where the sleep and waking is kind of partitioned across the day, or even with larger animals, we tend not to think of morning and evening. We just think of light and dark periods, or if we want to do these very artificial light pulses, like I showed in the slide. So.
It's very nice. In animals, you can control anything. You know, you cannot tell people to just sit in the dark for an ex. It's just impossible. So it shows how the research in both areas is very complementary in that sense. You know, it's very nice.
So for Jeffrey, with respect to the acute effect of light affecting people's sleep after time zone travel, would you prohibiting light at the endogenous nights be enough to prevent the detrimental effects?
So jet lag recovery is a very controversial subject as well. So there's a lot of anecdotal evidence. There's limited empirical evidence as to how this works. And it also there's so many factors that go into play. I think one thing that really hurts is especially flying to the west. So flying to California, back to work, Renske. Flying back to work, that the exposure of light in the airplane is really bad. And not to mention the fact that people drink alcohol, they don't drink enough water, they don't move, the food is a bit iffy, you know. So that really, then you land maybe at 3 or 4 in the afternoon, you're completely exhausted because your circadian clock is at 5 in the morning. That you should probably be trying to expose yourself to light while you're on the plane to kind of start boosting this a bit. I think the main thing is with long jet lags, the first day is a wash because it's anyways not even a circadian issue at that point. It's just a fatigue issue. There's a lot of sleep pressure. You won't really start feeling the effects until the second or third day. And then, you should try to slowly expose yourself a bit. You know, early morning light exposure always works well. And not using your phone in a dark room, regardless of what color the light is coming out of it, is probably not a good thing. Going east is a bit trickier because it's so unnatural flying east that you even run the risk of flipping your cycle if you're not careful. So try to get light exposure, but I think it's also physical activity is very important. Light exposure by itself is not a panacea for solving all of our problems, as much as we would like it to be, you know. So I think also going outside and having light exposure, even for a walk, you know, trying to stabilize when you're eating, you know, that you're not just eating whenever you're hungry. I think this really helps. So,
Yeah.
Okay, and staying a bit in the travel field, are there any studies on the sleep behavior of people who live far away from the equator, for example, in the north of Scandinavia, where there are extreme day-night cycle? And what was their sleeping behavior like before the invention of electric lights?
Yeah, that's a great question. There are some studies in these kinds of populations, and it's really interesting because they're not that different from people that don't live that far from the equator. And we think that there is some sort of genetic predisposition to this because they will tell you, you know, like living in the dark for almost 24 hours a day, not everybody is resilient to that, right? Like seasonal affective disorder is a real disorder, which means depression in winter when there's decreasing daylight. And people at these kind of latitudes do not report that at all or very little. And we think there are some, genetic predispositions to be resilient to these kinds of things. And because otherwise it's impossible to live at these extremes. Yeah.
Okay. What can be said about morning person and night person? What are the differences in the brain process between the two?
I mean, that's a great question. We don't really know. I think when we talk about an evening person versus a morning person, we take it as an output of the circadian clock, such that an evening person tends to be, let's say, a later chronotype in which the circadian clock ticks a little bit slower, whereas a morning person would be somebody for whom the circadian clock ticks a little bit faster. I think it's really an endogenous preference. Like you like to be a morning person, you like to be an evening person. And yeah, you can amend that a little bit with light exposure, for example, but it will always be your endogenous preference. If it really, really correlates exactly to, yeah, to what happens in the SCN or what happens in the brain, I don't think we really know right now. That's my take on it, at least. Yeah.
And about that, regarding your first study about late people who go to bed late are more exposed to depression, did you check for chronotype? Because in my view, it would be that late chronotype wouldn't be affected so much, and that early chronotype that goes to bed late then would be affected a bit more.
Yeah, so there was a little bit more to the story than that I told, because our question was indeed, a lot of people have this kind of, let's say, desynchronization where they are an evening person, but they have to go to bed early because they need to go to bed, they need to go to work early, for example. So we were really interested to see if this kind of desynchrony is worse for physical and mental health outcomes. And the conclusion was that no, it's not the mismatch between what you like to be versus what you are. It's really the timing of behavior that drives mental and physical health disorders. Yeah.
Okay, I didn't know that.
Yeah.
And can you comment on the intensity of needed daytime light exposure, specifically indoor electric versus indoor daylight versus outdoor daylight?
Yeah, I am very resilient to make recommendations about lux in that kind of way. I think there are many factors to take into account. Light history, have you been outdoors? I think there are differences, inter-individual differences in light sensitivity. So I would be very hesitant to put a number on that. I think there are some recommendations for at least 250, I think, melanopic EDI, so light intensity specifically for the photoreceptor that translates most of the knowledge to the SCN. Yeah, so those are the scientific recommendations right now, I think. Yeah.
Okay. How do changes in the pupillary light reflex in children who are neurodiverse impact sleep regulation?
That's a great question. It's not quite my area of expertise. All that I know is that I think there is some emerging literature suggesting that children with neurodivergence are more light sensitive, and that this is one of the reasons why they're more prone to phase delays, why they like to go to bed or tend to go to bed later and have lots of sleeping problems. So it might be a light sensitivity thing, where probably reducing light intensity is the best way to approach it. But yeah, it's not my area of expertise at all. Yeah.
And would you advise for people with insomnia to absolutely avoid light during the night, or when they use stimulus control and get out of bed, could they watch TV if it's relaxing, so lowering stress versus avoiding light?
Yeah, this is a very complicated question because from a biological perspective, I would say try to avoid light as much as possible. But sleep is a very interesting phenomenon, at least in humans, where it's a combination of physiology and psychology. And your physiology can be at one point and at the right point for sleep, but the psychology is not there. And I think for some people, watching TV can be very relaxing and help get the psychology part, in the right mindset for sleep. So I think for insomnia, most importantly, I would say, yeah, what works for you. I think there is a balance between what we would recommend for the biology versus the psychology. So yeah, it's kind of a dodging answer.
It's always like this with insomnia, so
Yeah, it's very difficult. Yeah.
Yeah, it should be a balance between both, I guess. And, yeah.
Yes.
There's quite some literature that's not only the intensity, but also the wavelength of the light is important. LEDs lack both in the cyan as the deep blue and UVA, UVB part of the spectrum. This impacts the OPSING 5 and IPRGC. Do you agree that the spectrum is relevant? And if yes, how should the ideal spectrum look like?
Uh,
Sorry.
I mean, we talked about it a little bit. I think, yes, spectrum matters. I think light intensity probably matters more in a way. As long as you get enough of a certain light intensity, it will have an effect. Yeah, I don't know. Does Jeff have any ideas on this?
About what's
Passing it along.
the best light to design.
Yeah.
I mean, look, the information on option 5 also there's not so much research that's been done on option 5 to this point. UV spectrum also have to be very careful about what you include in light because it can be quite damaging to human retinas. To mice, it's a bit different. They have ultraviolet sensors, they're receptors, but then they don't see red light. So everything is a trade-off. But I would say what the ideal spectrum to look like, if you look at the sun, there is no difference between the amount of energy which is produced based on the frequency. So we're always trying to adapt this, but to say that one thing is more important, maybe we'll discover another photoreceptor in 10 years that is somewhere in between these other two, and then we realize all of our LEDs have nothing there. So, it's human beings are very adaptable, and we always find ways to do it. So
how cool would that be, a new photoreceptor?
new photo, you never know.
Yeah.
Option 6.
Okay, so maybe because time is running, but our last questions. How do animals light researcher and human light researcher work together?
That's a good question. We try to do as much as we can. I think it's important to remember that translational research from animals to humans also goes the other direction. So it's a constant interaction from fundamental research to basic human to clinical research. You cannot just say we use animals to understand something in humans because maybe we'll discover something in the animals and then find something in humans or vice versa. So I think at least from my perspective, we try as best we can. Of course, as I said before, we have a lot of control over what we can do to modify the animal's behavior, to modify their genetic background, to modify their physiology, which you don't have in human beings. So, yeah, I don't know if you have what your feeling is on this, Renske, but
Yeah, I think I would completely agree. I think there can't really be one without the other. I do really think so. A lot of the ideas that we get for our translational or clinical implications really come from animal research, and similarly, a lot of the clinical, let's say, malfunctions can be replicated in animals because you have the control about genetics and yeah, I really think there can't be one without the other, and we try to collaborate as much as possible, but it can be challenging for many reasons. You become such a specialist in your own little niche. But I always read papers from the animal work, and yeah, I think we need each other for sure.
Okay, thank you both of you for answering all these questions and for your great talk. And thanks again for the organization to provide such amazing deLIGHTed talk. Thank you for everyone who was there and asked questions. And I hope we see you very, very soon. So thank you very much.
Thank you so much again for inviting us.
Thank you.